those who are here and those who have joined us on various live stream. Thank you for being with us today. My name is Sayeed, and I'm a developer at Thoughtworks, and I'm really excited to talk to you all today. So let's get started with some questions, right? How many of you have written integration tests for your services? By a show of hands. Good. And how many of you are familiar with the concept of integration tests? You might not have written, but are you familiar? Okay, it's good. So for those of you who don't know what integration test means, just think of it as another category of automated tests like unit tests. How many of you agree with this quote? Show of hands. Yep. I too agree with this quote 100%. You cannot have good quality software delivery without automation test. And when we talk about automation test, integration test is also an integral part of that. Okay. Let me share with you a story from my project, right? So last year, me and my team were trying to debug a performance issue, and every time we would make a change and push the commit, the build would take about 25 minutes to run. Now, imagine that you are blocking a critical release and you are just sitting there watching the build run for 25 minutes. And on top of that, you're getting pings from all your stakeholders about updates, right? So 25 minutes waiting for a build for 25 minutes can be really frustrating. Now, here is a quote from Martin Fowler's website, which tells us how long a build should take, right? It says the build step should not take more than 10 minutes. So the build process that generates the artifact, it should ideally take less than 10 minutes. So after that frustrating experience that I had waiting for the build for 25 minutes, I started looking into why the build was so slow. And I realized that we had written too many integration tests. And integration tests tend to be slower than unit tests, and that's why the build time was very high. So that prompted me to ask myself a question. How do we integration test the right way? And that's what I am here to talk to you all today. How do we integration test the right way? So at the end of this talk, I am hoping that we would have covered a few things. We would know what integration tests mean, what value do they provide, how do we write integration tests the right way. We will see some sample code. And we'll also see some anti-patterns, which basically led to that long wait time I just described. Sounds good? Okay. So before we dive deep into the topic of integration tests, let's back up a bit and understand what are the typical microservices tests we have. So we have unit tests, we all are familiar with it. Then we have integration tests. And we have contract tests. So these tests run as part of the build step. Right? This is pre-deploy. So these tests run and you have an artifact after which you go into the deployment to an environment, and then you run either your functional tests or API tests as you call them. And you may also run performance tests. So this is what a typical microservice test pyramid looks like. And today our focus is on the integration tests part. So typically when you have a microservice, it would be talking to other components like a database or another service. It could also be talking to a message queue. Integration tests basically help us validate that the microservice is able to connect successfully with these components. Right? So how does a typical integration test flow look like? So you have a microservice, and let's say it has a database. That is the component that it is integrating with. So a typical flow would be 4 steps. First, you would, for an integration test, the typical flow would be 4 steps. You would start the component, which is database in this case. You would start the microservice. We would trigger an action in the microservice that causes an interaction with the database. And then we would assert that the interaction happened as expected. These are the 4 steps of a typical integration test. Some other characteristics of integration tests. So we would typically write a separate test for each component. We would also mock the components so that the tests are reliable and fast. And we don't need to have all the components running to test integration with one component, right? So a microservice can interact with multiple components. You want to test integration with one component, you don't have to have all the other components running. So these are some other characteristics. So what value do integration tests provide? They help us get fast and closely simulated feedback on integration that unit tests cannot provide. Because in unit tests, you cannot spin up other components and test your microservice integration. It's only integration tests that can provide you that feedback. And why we say closely simulated is because some of the components are mocked in integration tests. So it's not a real feedback, but it is a closely simulated one. And it is fast. Because we are getting it in the build phase. So far we have seen what integration tests mean and some of its characteristics. But the real question that we are trying to answer is, what is the right way to do integration testing? How do we test integration with one component? Right? How do we know we are doing the testing right? How do we know we are not over testing? And how do we know we are not getting into any of those anti-patterns which can increase your build time? So that's what we are going to cover in this section. And this is the crux of the presentation as well. So the example that we are going to look at will be based on Java and Spring Boot, but the concepts can be applied to other tech stacks as well. Now think about this, look at this example where we have an order service, which is our microservice that we are trying to test. It exposes some REST APIs like create order or get order. Those REST APIs are secured through an identity provider like Okta or Auth0, which governs the authentication and authorization. Now, when the order is created, what order microservice does when an create order endpoint is invoked is it saves the order in the database. It makes a call to the notification service to notify the customer that they have placed an order successfully. It also calls loyalty service to update the loyalty points for the customer for placing this order. It places an order placed message on a queue for some other systems that might be interested in listening to that event. And once the order is successfully shipped, it listens to the order shipped event on another queue. So it's reading messages from the order shipped queue, and it is writing messages to the order placed queue. So first order is placed, and later at some point when it is shipped, it listens to the shipped message. Right? So all in all, like this is a good example of an order microservice and some of its components. Now let's look at how we would integration test order microservice with all its components through some code. So first, let's focus on the API calls, the REST API calls that are happening from order service to notification service and loyalty service. So let's look at some code. So here we have a source code written in Java. It's a Spring Boot application. And we have our different components grouped in different folders here. So we have the API client. So we have a loyalty client which talks to the loyalty service, and we have a notification client which talks to the notification service. And then there are some configurations, right? So let's look at notification service. What it is doing is basically sending a notification to the customer that the order is placed. Right? So it just uses REST template to make a post call, and then it has some error handling here. So how do we integration test this notification client, which is basically interacting with the notification service component? So the idea is that we just add one integration test to cover 1 to 100 response for any one of the endpoints for notification service, right? And everything else in this class can be unit tested. So let's look at how that looks. So here is the test class. We are using, as we spoke earlier, that the components can be mocked. So we are using wire mock to mock the notification service while we are testing the order service. What we are doing here is there is an endpoint in the loyalty service, which is called add loyalty, and we are doing an integration test for that. So this is a Spring Boot test, which basically means that the whole application will be initialized, all the context and beans will be initialized. And we would just test the loyalty client. So loyalty client is injected here, which is part of the application code. And we are testing that the add loyalty method is successfully able to talk to the loyalty service and get a response. And we are, because we are using wiremock, we are stubbing the response to be a success. And this is the only integration test we need for the loyalty service integration. Now let's look at what are the integration tests in the notification client. So here we are testing one, the send notification method for 200. And then this is an interesting one. We are also testing retry behavior. What we mean by that. So let's say that you have a client and you have implemented retry behaviors for your network clients when they are talking to other components, and you want it to retry 3 times and then fail. If it fails all the 3 times, let the API call fail. Now this is something you would achieve through some annotation provided by Spring Boot, some framework level methods. And if you want to test that retry behavior is intact or it is working as expected, you can write one test for all your network clients, right? Because this retry behavior being a framework behavior, you don't have to test it with every client. If it works for one client, because you are going to use the same annotation for every other client of yours, you can just make do with one test. And that's what we are trying to test here. So we have a method which is going to test the retry on failure. So what we are doing, we are stubbing for a failure from Wiremock, and we are testing that it is the post notification call is happening 3 times, because we have specified 3 retries here, and there is a back off logic, all of that. But we said 3 times retry, we use the annotation, and then we are validating that in the test, that it is indeed making 3 calls. Now, this is all we need to validate that the retry behavior from the framework that we are using is working as expected. This is just one test. We don't need to test retry in any other client because we will be using the same annotation elsewhere also. So the retry behavior is validated. Likewise, if you have circuit breaking behavior or any other behavior, same concept applies, right? So if you have something which is operating consistently as if at a framework level on all your network calls, then just have one integration test for that. So far for all our network clients, which is the notification client and loyalty client, we have written one integration test for the 200 case for both of them, and then we have written one for the retry behavior. So these are the 3 integration tests which covers all our integration with the external API REST API services. Any questions so far? Great. Now let's go back. So we have covered everything on this side. We have covered the integration tests for all our other services that order service is integrating with. Now let's look at the order database. So what kind of integration tests we want to write for order service integration with order database? So to interact with the order database, we have a repository class called order repository. And in that, we have some methods that we have created. We are using JPA for interaction with the database. And we have some methods like find by customer ID, find by order name, order number. And then let's say we have these hypothetical methods which are custom queries, right? Now, what is our strategy to integration test this order repository? So the recommendation is that we just have one integration test to save and fetch the entity that the repository is created for. Let's see what that looks like. So we have this order repository integration test where we are saving an order and then validating that it is saved successfully. Now you may ask, but we have many other methods here. Why are we not testing this find by customer ID, find by order number? These are also methods here, right? So why are we not testing that? So the answer to that is simple. Because these methods are generated by JPA and should work as expected, and it's straightforward, we don't need to necessarily integration test this. Right? As long as we are able to save an entity and fetch it, like that can give us sufficient confidence that the order service is able to successfully talk to the order database. Right? We don't need to test all of these methods, simple methods that we have designed, that we have added here. Just one caveat that applies is if you have something which is having a complicated custom logic, right? So this is a complicated custom query. It can get very complicated in some cases. In those cases, if you want to add an integration test for that specific scenario, you can. But it is not recommended for very simple methods like this. Similarly, if you have a query that looks like, if you have a method, JPA method, which looks like this, right? So you are trying to find by customer ID and order status payment method not null. So you are going and checking 4 or 5 fields in that derived query method. In that case, if you wish, you can add. So these are special conditions and will depend on your context. So if it is complicated and very critical, you can add one integration test for that. But this is where we have to exercise caution that we don't go overboard and start over testing, because then we will run into the challenge of slow build time. Now we have covered the order database. Let's see about the queue to which the order service is writing when the order is placed. So let's look at this integration. So you have a queue and order service is writing a message to the order queue when the order is placed. So how do we integration test this? So this is the class that writes to the message queue. And this is the class where we are integration testing it. So basically we are creating an order. When the order and create order endpoint is called, we have the order entity and we are uh, sending a message to this queue saying order is created. So we are basically RabbitMQ we are creating through Docker, and then this integration test runs, and we will see how the whole hierarchy is there between the different services and the dependencies. But the idea is by the time this integration test runs, you already have an MQ setup, and then this is just sending a message to the MQ. And we have a test listener here, which listens to that message just to validate that the order is indeed going to the queue. Right? The order placed message is indeed going to the queue. It has some logic of waiting for the order reception and all. It uses semaphores, etc., which you can look at in the source code when I share. But high level, just think of it like this. You have, when your order is placed, an MQ is created already through Docker, and then notifications, order service is placing the order message on the queue. And in the test, you are validating by creating a test listener that message is indeed being sent by the order service. And that is all we are going to test here. We are not going to test if exceptions are going to be thrown or all of that. We just want to test that the integration is working as expected, right? That the integration is intact. The configuration is not messed up. Service is able to talk to the queue to write message. That's all. So we have covered the order placed, message sending. Now let's see what happens when the order is shipped and we are getting a message in order service that the order is shipped. So we would read that message and update the order status. That's what will happen in this. So first, looking at the listener. So we have a queue on which we are listening, and we are getting the order shipped message. We are finding from the repository that exact order and just updating its status to shipped. What does the integration test look like? Simple. You already have the MQ running. So we are sending the order shipped message through a Rabbit template, and then we are waiting for the order to be received by the service because this is the flow. And once it is received, it would go update the order status, and we are finding that order and validating that the status has changed to ship. This is all we are doing. Right? And we are doing this through a dummy, like from the test class, we are sending a message that order is shipped, which is processed by the order service, and order status is updated. That's what we are validating. That's all we need to do in this. Any questions so far? Any doubts? Yeah, that we will cover now. I'll show you that. That's being done by the repository class. Hmm. Yep. So this is our listener. We are getting the message. We are seeing if we actually have that order or not through the repository. So this listener has an instance of the repository, right? No. And we are finding, and then we are validating. Any other questions? Okay. So we have seen, by now we have seen order service integration with the REST APIs, the queues, the message queues, and also the database. The last part that remains for this example is when the REST API itself is invoked, it has authentication and authorization. So for that, to validate the tokens, etc., the notification service is going to call to the auth server and validate whether the token signature is right or not. We need to test that as well, because that's, again, auth server is an external component, and we need to know that the authentication authorization is intact. So we would be having multiple endpoints in this service, say create order, get order, etc. But the integration test is going to be just for one endpoint, because all we want to make sure is that the application is, the order service is able to talk to the auth server, right? Now, which endpoints have authorization or don't have authorization will be controlled by the order service itself. There will be some security configuration which says for these path patterns apply authorization, right? Now, we can unit test all the path patterns. We don't need to test that each of those endpoints is able to reach out to auth server, right? Any one endpoint is fine. The rest can be unit tested. Right? All we want to do in integration test is validate that the application is able to reach the auth server. We don't want to validate that every endpoint is able to reach out to the auth server. Those are things we can do in unit test. Let's look at the code. We have this security configuration class, which is basically applying, which requires the scope to be this for any endpoint that looks like this. So anytime we try to create an order, this will apply. So we are going to then have an OAuth integration test. We will call it OAuth integration test or auth 0 or whatever. Right? OAuth seems better. Here too, we have wire mock to return mock responses from the auth server. We have a REST template to invoke the create order endpoint. And we are going to stub the calls that the order service will make to the auth server. So it will make two calls, one for configuration and one for getting the JWKS, which is the key set. So those things are stubbed. So basically you are stubbing the response from the auth server, and you are trying to do a post order, create the post create order endpoint, call the create order endpoint. And there are three tests in this. One for 401 when there is no token, one for 403 when token is there but scope is invalid, one for 200. Now we don't need all three. We just probably need one for 200 and one for 401 or 403. Right? If you have 403 and you validate 403, 401 is automatically validated because it's able to talk to the auth server and 403 is working, so 401 will work, right, for that endpoint. And if you don't have like authorization scopes, etc., and you just have some authentication logic and you only get 401s, then just test the 401. Right? So if 401, 403 both are there, test only 403. If you don't have 403 responses, like you don't have authorization, just authentication, test 401. So it will only be 2 integration tests, and that is all for auth server integration. Yeah, it will. So we would, when we are writing the integration tests, some cases it will require, some it won't. So I'll give you, that's a good question actually. So let me show you. So this test does require other components to be there because you want to spin up the service and database and other things will also come up. But let's look at one test, which is the database related test. This is the database integration test, and we have used data JPA test annotation here instead of Spring Boot annotation. What this means is that you don't need to spin up MQ for this, right? And you don't need to mock your auth server calls, etc. This data JPA test by design will only start the application with bare minimum context that is needed. It will not look for other beans and other dependencies. So you can just have this, and with this, if you are using, let's say you are using test container for your integration test, you can use test container or Docker, both is fine. We are using Docker in this case where when we run the tests, the dependency components like the MQ and database will come up first, and then the application integration tests will run. But you can do it other way also. You can just have in this test test container for database. Right? In that case, all you need is your application, and which is here, and then the test container for database. That's all you need. So it depends on which style you choose and which annotation you choose. If you are going with test containers, you can minimize your other containers that you're spinning up. If you're going with Docker containers approach, then you may not be able to minimize. And also if these annotations are provided, in some cases you can minimize the dependency components that you're spinning up, which will make your test fast. Any questions? A good question. I will answer that through a question, right? So when we are having a microservice and there are components, which is the code which is closest to the component? That's all, right? Because you are trying to test the integration, you already have a handle to the door, right? The repository class is what is going to talk to the database. You can already reach that. Test that and the onwards link. Unit service to repository, you can unit test. Yeah, and you don't need to duplicate that in integration test. Only at the boundaries. Make sense? Any other questions?
That seems right. So, if my service is an API, I want to do a test from calling my whether it should be an integration task or a unit test, because it covers all the service and what we talked about, the repository services and then resistance everything.
Though that would be probably post deploy. So you may want to deploy the service and then test whether it is able to connect to the actual dependencies and have one test for that. See, through what we are trying to do is also not over test something that we have already tested, right? Now, if you already have unit test, on top of that, you have written integration test. So now you are making sure that the application is able to talk to the components properly. You already have unit tests in place. On top of this, if you are writing something for a full validation, then you have to be selective on how much you want to do that. You already have a layer of test, two layers of test below, unit and integration. Finally, when you want to test like everything from end to end, I would probably go with very simple one happy path for one or two flows, right? So maybe two, three endpoints. That's all. Rest is already tested in the lower layer, in your unit test and in the integration tests. Any other questions? Okay. So we had a look at the sample code as well. Now, if you want to look at the sample code, this is available on my GitHub, personal GitHub. You can search for Sayeed Hussain on GitHub and find this order service. You will get all the code. Let's quickly look at some other, what we discussed just now is the bare minimum scenarios we need. Now, there are some other potential scenarios where you might need integration tests, and that will depend on your context. So we discussed a bit about this. If you have complex custom queries, SQL queries, then you may want to. Again, you have to take that call. That's your judgment call. What we discussed so far is mandatory. Everything here onwards is going to be more judgment driven. If the query is too complex and you think it is worth having an integration test, have it. Similarly, if you have a very complex derived, so this is a custom query and this is a derived query, where you take the field names of the entity and then construct a method, right? So JPA provides this. Now here we are trying to find a customer in find find the order which is within these cities, list of cities. Minimum amount is this, maximum amount is this, has a product name like this, and order date is after this order date. So we have already reached like 4 or 5 parameters. At this point, it is getting complex. So if you want to add an integration test just for this method, you can add. But don't add for find by customer ID. That's just one parameter. 4 to 5 is what you should start thinking if you need one. Again, that will be a judgment call. This we already discussed, like if you have a framework behavior, which is cross-cutting across all your maybe network clients in this case, then you can write one integration test to validate that this retry is working as expected, right? This will help you also ensure that when you are upgrading this library which has this retry, etc., that behavior remains intact. Sometimes it might break and you won't know. So if the retry behavior is very critical for your application, then that one integration test that you wrote will serve you well. Let's quickly look at some of the anti-patterns of the integration test. So what are the common anti-patterns? There are 3 of them. First one is when you have your microservice integrating with a component, you can always over-test the integration. What I mean by that is in our example of order repository, we had those find by customer ID, find by order name. So those simple methods were there. You could write integration test for all of those. But what we recommended is just have one to save and fetch. That's all, right? But that one integration test will tell you whether your order repository is able to talk to the order database or not. If you have more repositories, have one integration test for each repository to do save and fetch, right? That's all. But if you have methods like find by customer name, find order by customer name, find order by ID, those methods you have written, those are just simple JPA methods. Don't write integration test for each one of them. That is when you would run into the over testing situation. And again, consequence of that is slowness, right? You will have slow build times. So don't over test a component. Mostly that is driven by unit test. Integration test will not provide you that metric. So if you have good coverage at the unit level, that's what maybe a Jacoco will validate.
Depends on the core coverage to integrate that's anti-pattern. Most probably from the down to top. So usually cover most of them in your unit test, and then the component test, and then comes the integration. And we unfortunately in our project we are doing for core coverage we are doing
Right. So yeah, that was my question. Like, has anybody implemented this anti-pattern? Okay, great. See if you can change. Anti-pattern number 2. Validating microservice functionality end-to-end to answer your question, right? So imagine a scenario where you are trying to create an order and that will, you are invoking the create order endpoint in the microservice, order service. That is saving the order in the database, and then that's also sending an order placed message to the message queue. Now, if you have an integration test that validates that when I post an order, the order microservice is able to save the order and also send the message to MQ, you are basically trying to now validate the functionality of the microservice. This is already covered in your unit test plus individual component integration test. Now you don't need another integration test to validate this journey. This is already covered. So anytime you try to go and start validating your microservice behavior, know that you are already duplicating. Unit tests plus your component related integration tests, the minimum ones, are already giving you this feedback. So don't repeat that. If you do want some of this, then do it post deploy, and that to bare minimum. You have to identify what is the bare minimum 2-3 endpoints you need to test post deploy. This is not for integration testing. This scenario is not for integration testing. The third anti-pattern is duplicating with unit tests. Now, if you have a network client that is throwing an exception when you invoke the third party or the other external service, and you are trying to validate that in integration test, you are basically repeating what you are already doing in unit test. Just test the 200 single endpoint in that client, and that's all you need to test, right? You don't need to test anything else. Anybody doing this? Okay. And anybody doing this in their integration tests? Validating whole? Okay. Cool. Okay, cool. So I think we are also on time, and the summary, right? So in conclusion, what is our key takeaways? Yes. Identify minimum scenarios to validate integration with a component. You saw how frugal we were when we were identifying each scenario. Just do one. So have that mindset. You need to consider some scenarios specific to your context, which might require additional integration tests beyond the bare minimum that we discovered, right? And yeah, the 3 anti-patterns that we discussed. Over-testing single component integration by validating each and every method. That's one. Second is validating the microservice functionality end-to-end. Don't do that. Third one is if you are duplicating logic with unit tests, don't do that. that was mostly it. Any questions? Yeah, I'll show you that. So we have, yeah, you can also look at this in the source code by going to my repository, but I'll show you this. So we have this Docker Compose where we have created this order service and we have dependencies on database and RabbitMQ, which are also Docker containers. Remember, you can do this with test containers also, in which case you won't take this approach. You will just spin up the containers using test container library in the integration test itself, and then that will also work. But I have taken this approach, an alternative approach. So this is what, so you, for order service to come up, it requires these two. Now I will execute a command. I'll first down the containers and then I'm doing Docker compose run order service and then Gradle build in that. So first the dependencies will come up, then Gradle build command will be executed, which will ensure unit tests and integration tests are run, because both are part of build step. Yeah, so it ran. So we have total 9 tests and all of them passed. You can check. And it took like 10 seconds. Right? So 25 minutes and 10 seconds. Yeah, this is just like a simplified scenario. You may have more components, etc. But still, if you take this approach, you will end up in a much better state and you will be able to meet the less than 10 minutes recommendation from Martin Fowler. Any other questions? Okay. Thank you for listening.